Enter Multivariate Adaptive Regression Splines, MARS. Now, before we get into the nuts and bolts, let's set the stage. Today, we'll be unraveling MARS from the ground up. We'll start with the fundamentals, where you'll see why this technique is such a game changer for high-dimensional nonlinear data. Then, we'll break down how MARS actually works, moving step by step through its two-phase approach. The forward pass, where we aggressively add basis functions to fit the data, and the backward pass, where we trim away the excess to prevent overfitting. Sound familiar? It's like sculpting. First, you gather as much clay as possible. Then you carefully carve away the unnecessary parts to reveal the masterpiece underneath. We'll also talk about the key mathematical components behind MARS: basis functions, splines, knots, all of which work together to create a model that can flex and bend to fit complex relationships. From there, we'll dive into the challenges: overfitting, computational complexity, interpretability issues. Because, let's be real, no model is perfect, and MARS has its fair share of trade-offs. But don't worry, it's not all theory. We'll look at real-world applications in finance, healthcare, marketing, places where MARS isn't just a fancy algorithm, but a tool that drives real business decisions. We'll even go hands-on with a case study on housing prices, where MARS outperforms traditional linear regression in capturing price variations. And if you're wondering, where is this heading? I'll leave you with this thought. What if MARS isn't the end, but just the beginning? What if we could combine it with machine learning techniques, optimize its computational efficiency, and push its capabilities even further? That's where we're headed, into the future of MARS, where hybrid models and automation might just take it to the next level. So, if you're ready to see how MARS can transform the way you model complex relationships, let's start at the beginning. What exactly is MARS, and why should you care? All right, let's set the scene. Imagine you're navigating through a dense jungle of data, variables intertwining like vines, relationships hidden beneath layers of complexity. You need a guide, a machete to carve through the chaos and reveal the patterns underneath. That's exactly where Multivariate Adaptive Regression Splines, or MARS, comes in. Now, I know regression splines might sound like just another buzzword in the endless world of machine learning, but trust me, this is no ordinary modeling technique. MARS is like a master sculptor. It doesn't just fit a rigid equation to your data. It adapts, breaking it into meaningful pieces and shaping it to reveal the hidden structure. Traditional models, they assume too much, impose strict linearity, and struggle with complexity. MARS, it bends, flexes, and adjusts, making it one of the most powerful tools for uncovering nonlinear relationships. But here's the catch. MARS is both brilliant and deceptive. It builds itself up quickly, adding as many details as possible, only to then cut away the unnecessary, leaving behind something refined. Sound like magic? It's not. It's pure mathematical strategy. So, what exactly is MARS? How does it take raw data and turn it into a predictive powerhouse? And more importantly, how can you use it to gain insights, make smarter decisions, and maybe even outsmart traditional models? That's exactly what we're about to uncover.